A key challenge associated with unattended workspaces is minimizing energy waste. To address this, it's crucial to pinpoint the unattended areas where power supplies can be safely shut down. Huawei Wi-Fi 7 APs employ cutting-edge CSI sensing technology to detect human activities in their surroundings, effortlessly locating unattended areas without the need for additional hardware. But how does this innovative technology work? During transmission, Wi-Fi signals interact with their surroundings, producing reflection in addition to direct radiation. These signals arrive at the receiver through multipath overlay and are embedded with channel state information. CSI can reveal the impact of environmental reflection on signal propagation. In the absence of moving objects, the amplitude and phase of each CSI subcarrier remain relatively stable. Conversely, when individuals move within the space, variations in signal reflection occur due to human body movements, causing significant changes in amplitude and phase. Building on this mechanism, Huawei Wi-Fi 7 APs receive their own Wi-Fi signals similarly to radar systems. Each AP can autonomously collect CSI data, using detection algorithms to identify both large-scale body movements and even fluctuations in breath. CSI sensing technology seamlessly collaborates with Huawei's intelligent network analysis platform and third-party application systems to deliver functionalities such as physical digital map display, intelligent shutdown of electrical devices, and intrusion detection. In this way, CSI sensing enables campus networks that feature converged sensing and communication, as well as energy conservation. A key challenge associated with unattended workspaces is minimizing energy waste. To address this, it's crucial to pinpoint the unattended areas where power supplies can be safely shut down. Huawei Wi-Fi 7 APs employ cutting-edge CSI sensing technology to detect human activities in their surroundings, effortlessly locating unattended areas without the need for additional hardware. But how does this innovative technology work? During transmission, Wi-Fi signals interact with their surroundings, producing reflection in addition to direct radiation. These signals arrive at the receiver through multipath overlay and are embedded with channel state information. CSI can reveal the impact of environmental reflection on signal propagation. In the absence of moving objects, the amplitude and phase of each CSI subcarrier remain relatively stable. Conversely, when individuals move within the space, variations in signal reflection occur due to human body movements, causing significant changes in amplitude and phase. Building on this mechanism, Huawei Wi-Fi 7 APs receive their own Wi-Fi signals similarly to radar systems. Each AP can autonomously collect CSI data, using detection algorithms to identify both large-scale body movements and even fluctuations in breath. CSI sensing technology seamlessly collaborates with Huawei's intelligent network analysis platform and third-party application systems to deliver functionalities such as physical digital map display, intelligent shutdown of electrical devices, and intrusion detection. In this way, CSI sensing enables campus networks that feature converged sensing and communication, as well as energy conservation. A key challenge associated with unattended workspaces is minimizing energy waste. To address this, it's crucial to pinpoint the unattended areas where power supplies can be safely shut down. Huawei Wi-Fi 7 APs employ cutting-edge CSI sensing technology to detect human activities in their surroundings, effortlessly locating unattended areas without the need for additional hardware. But how does this innovative technology work? During transmission, Wi-Fi signals interact with their surroundings, producing reflection in addition to direct radiation. These signals arrive at the receiver through multipath overlay and are embedded with channel state information. CSI can reveal the impact of environmental reflection on signal propagation. In the absence of moving objects, the amplitude and phase of each CSI subcarrier remain relatively stable. Conversely, when individuals move within the space, variations in signal reflection occur due to human body movements, causing significant changes in amplitude and phase. Building on this mechanism, Huawei Wi-Fi 7 APs receive their own Wi-Fi signals similarly to radar systems. Each AP can autonomously collect CSI data, using detection algorithms to identify both large-scale body movements and even fluctuations in breath. CSI sensing technology seamlessly collaborates with Huawei's intelligent network analysis platform and third-party application systems to deliver functionalities such as physical digital map display, intelligent shutdown of electrical devices, and intrusion detection. In this way, CSI sensing enables campus networks that feature converged sensing and communication, as well as energy conservation. A key challenge associated with unattended workspaces is minimizing energy waste. To address this, it's crucial to pinpoint the unattended areas where power supplies can be safely shut down. Huawei Wi-Fi 7 APs employ cutting-edge CSI sensing technology to detect human activities in their surroundings, effortlessly locating unattended areas without the need for additional hardware. But how does this innovative technology work? During transmission, Wi-Fi signals interact with their surroundings, producing reflection in addition to direct radiation. These signals arrive at the receiver through multipath overlay and are embedded with channel state information. CSI can reveal the impact of environmental reflection on signal propagation. In the absence of moving objects, the amplitude and phase of each CSI subcarrier remain relatively stable. Conversely, when individuals move within the space, variations in signal reflection occur due to human body movements, causing significant changes in amplitude and phase. Building on this mechanism, Huawei Wi-Fi 7 APs receive their own Wi-Fi signals similarly to radar systems. Each AP can autonomously collect CSI data, using detection algorithms to identify.
Hello everyone, and welcome to today's IP Club webinar. I'm your host for today, Jimmy Ding. So today we're going to unveil a magical communications technology called Channel State Information, or CSI for short. It's a type of Wi-Fi sensing technology. To help you get a better understanding of this technology, we've specially invited two industry experts. First off, Ms. Zhuqing Tang, core member of the IEEE 802.11 BF Task Group and senior engineer at 2012 Laboratories, Huawei, and Mr. Han Liu, solution architect, enterprise data communication marketing and solution sales department, Huawei. First, let's invite our two experts to introduce themselves to the audience. Ms. Zhuqing Tang.
Hello everyone, my name is Zhuqing Tang. I'm the member of IEEE 802.11 BF Task Group and also the senior engineer in 2012 Laboratories in Huawei. And my responsibilities include the standardization of the Wi-Fi sensing standard, which is the 11BF, and also the research innovation of the Wi-Fi sensing and the product algorithm design of Wi-Fi sensing.
Hi everyone, my name is Han, And as a campus solution architect, especially now, I'm searching the new ways to how to collaborate with CSI, such new technologies, with the campus network solutions in different industries.
Okay, a warm welcome to both of you. So let's get straight to it. Recently, the term CSI, Wi-Fi, has been getting frequent mention in the industry. Because nowadays, Wi-Fi isn't just about internet access, but about sensing. So what exactly is Wi-Fi CSI and how did it come about? Ms. Tang, could you please explain this concept to us in some plain and simple language?
Yeah, sure. CSI sensing is a new innovation in Wi-Fi, driven by the evolution of wireless technology and the growing need for Wi-Fi to do more than just to transmit data. CSI, meaning channel state information, captures how Wi-Fi signals change as they travel through a room. With today's advanced signal processing, hardware, and AI, we can analyze these tiny changes to understand what's happening in the environment, whether someone is present, someone is moving, or even breathing. So essentially, Wi-Fi becomes more than just a communication tool. It becomes a way to see the environment through the electromagnetic waves, much like a lightweight radar built into every AP.
Thank you for the detailed explanation, Ms. Tang. So, as an expert from IEEE, could you tell us a bit about the development of Wi-Fi CSI technology as well as Huawei's contributions?
I'm going to present the standardization, industrial development, and technological innovation of Wi-Fi sensing. So this is the outline of this material. To begin with, I'll present the standardization of the Wi-Fi sensing, and after that, the industrial trend, as well as the WFA timeline. The timeline includes the sensing TG and Wi-Fi 8 TG. And after that, I will present how Huawei contributed to the ecosystems in three ways. First is the computations, and then the sensing dataset platform, and next is the ISAC ATI. After that, I present the technological foundations of Wi-Fi sensing, as well as the Huawei's core Wi-Fi CSI sensing technologies. So firstly is the standardization. So this page gives you a general overview of the standard. That is the IEEE 802.11bf, which is the name of the Wi-Fi sensing. First, let me define the standard, the Wi-Fi sensing definition. The WLAN sensing is the use of PHY and MAC features of IEEE 802.11 stations to obtain measurements that may be useful to estimate features of objects in the area of interest. The features include range, velocity, angular motion, presence or proximity, gesture, etc. And the objects include human, animals, and the area of interest is whenever we're interested, like the room, in the car, or in the enterprise. So this is the definition. And this part gives you an overview of the leadership of the standard organization. So here, these are the chair, the vice chair, the secretary, and technical editor. One thing I would like to mention is that the chair is affiliated with Huawei, which named Tony Han Xiao. Here is the timeline of this standardization. So initially, we don't have the standard, obviously. So the first theoretical proposals for Wi-Fi sensing emerged in the early 2010s, but this lacked support from the broader ecosystems. Based on that, we started our standardization. The industrial standardization began in September 2020, when the IEEE 802.11 working group approved the PAR, that is a project authentication request of a task group for the IEEE 802.11bf standard, called 11bf. And after 5 years of the standardization development, the standard finally released this year, this September. And one thing I would like to point it out is that during the standardization, the WFA discussion also happened in 2023. The Wi-Fi Alliance certification program is expected to start in 2027. These are the important time points I would like to mention. This page gives you an insight of the use cases that may be used by the Wi-Fi sensing technologies. These are the use cases that has been discussed in the standardization procedure over the 5 years. This use include smart home, presence and proximity detection, gesture recognition, gaming control, vital signs, location in store, audio with user tracking, sneeze sensing, and so on and so forth. Many uses has been discussed. That's a question I would like to ask audience. Which could be the killer applications? So this page shows the general architecture of the Wi-Fi sensing. The architecture can be characterized into 3 parts: the double-line sensing application, the double-line sensing agent, and the double-line sensing radio. The standardization mainly focuses on the double-line sensing radio part. Next, let me present the industrial trend of the Wi-Fi sensing market. This is the main figure. If you can see this figure, it is clear that the market for the Wi-Fi sensing devices continues to grow steadily each year. By the way, this figure illustrates the global installed base of Wi-Fi APs that are compatible with the Wi-Fi sensing for the period from 2022 to 2028. This figure was provided by the ABI Research, which is a company specializes in analyzing the global trends in the area of emerging technologies and wireless. Here I would like to also point out the standard is finalized at this point, and the growth is expected following the official 802.11 BF standards. Here I would also share with you the WFA timeline, the timeline of the sensing TG and Wi-Fi 8 TG. These 2 figures are the timeline, are the detailed timelines. I only would like to mention several important time points. The first time point is January this year. This is the time where we formed our sensing TG. And actually, if you compare the 2 figures, we can see that almost at the same time, the Wi-Fi 8 TG has also been formed. And finally, in this whole period, we will develop the MRD and the test plan. And the certification program will start in December 2027. And if you compare these 2 figures, we can also say that in the Wi-Fi 8, the certification also starts at almost the same time. Meaning that the timeline is aligned so that the 2 standards may be implemented in the same chip. This shows a very huge potential market. So in the next 3 pages, let me introduce how Huawei contributed to the ecosystem of the Wi-Fi sensing. The first contribution is the competitions. We have hosted 2 competitions. The first Wi-Fi sensing competition, which was held in 2003, and the second competition, which is a global competition called the SDP Sensing Challenge, which was hosted this year. So for the first competition, in this competition, we provided 2 tracks. The first track is the named detection and localization track. We give students the actual data set, which is collected by our products, and allow them to use this data set to develop the solutions that fit our product. And we were given a common benchmark to evaluate their solutions. For the second track, which is the innovative solution, we allow the students or participants to freely explore the technological innovation of Wi-Fi sensing. So that's the basic information of the first Wi-Fi sensing contest. And for the second contest, SDP Sensing Challenge held this year, we asked the participants to freely explore sensing technologies and application solutions based on AI. Okay, so the next contribution that we have contributed to the ecosystem is that we have established the sensing dataset platform called the SDP. This sensing dataset platform is the first large-scale actual measured sensing dataset platform. It was launched in last year, actually. Initiated by ISAC ETI and then collaboratively developed and operated by relevant professional organizations and individuals from both industrial and academic sectors. So this platform aims to provide rich scenarios, extensive use cases, and abundant high-quality sensing data set to support AI model training and algorithm research in the field of sensing. As I just mentioned, I said ATI, here it is. So this is the third contribution that we have made to the ecosystem. We have established the ISAC ETI, which is the first and largest international organizations which will link the academia and industrial for the ISAC. So this page, you can see these are the basic information of this ISAC ETI. Okay. Nextly, I will give you a technological overview of the Wi-Fi sensing. This page shows the technological foundations of Wi-Fi sensing. If we categorize the different sensing solutions, here it is, we can characterize different sensing solutions in terms of three aspects: the sensing configurations, sensing methods, and the sensing algorithms are listed here. I will introduce you one by one. So firstly, the sensing solutions can be characterized through the sensing configurations. The sensing configurations have three common configurations. One is the monostatic, and second is bistatic, and third is the multistatic. I'll skip the detailed description and just directly go to the most important part, what we have done what we have done. So for our Huawei's technology, we use single AP sensing architecture. By doing so, with this architecture, we can achieve the drawbacks that monostatic sensing already exists. Also, but the monostatic sensing has its own drawbacks. That is the limited coverage range. But we solve this problem. We can resolve the coverage problem by our algorithm and architecture design. The third categorization is the sensing methods. The sensing methods can be characterized into ISS-based sensing and CSI-based sensing. The CSI-based sensing is actually the mainstream method, and we also use this mainstream method. The CSI-based sensing has its own pros and cons, and we leverage the pros of the CSI sensing and also overcome some of its drawbacks. We provided our innovative solution, which overcome many issues that traditional CSI sensing often struggles with. The third categorization is the sensing algorithm. The sensing algorithm can be divided into model-based algorithms and AI-based algorithms. Our solution is the hybrid algorithms, and our solution provides a balance between the complexity and the functionality. So if you see the last column, give you a general overview of the Huawei's technology. And in the next page, I will show you the detailed technology innovation of our products. So here, these are the key innovations of our product. The key innovations can be divided into two parts. The first is a single AP sensing architecture, and second is algorithm innovation, hybrid algorithms. Let me introduce you the first innovation, which is the single AP sensing architecture. We have joint design. We have our innovative design. Our design is achieved by joint design across antennas, IF chains, and chipset level algorithms. These designs greatly reduces the transmitter and receiver non-idealities. And also, our algorithm and the architecture can effectively suppress strong self-interference. So this enables true photodirect sensing. That is, a single AP could transmit and receive simultaneously. Actually, this is the ability that's traditionally very difficult for Wi-Fi-based systems. With this architecture, here presented several advantages. The first advantage is the easy deployment. Since we only use one AP can do the sensing. So we don't need additional APs or stations to help me to do the sensing. Unlike many other Wi-Fi devices from other companies, many Wi-Fi devices, they would like to do the sensing. They need more than 2 APs to achieve the expected coverage, but we don't need that. The second advantage is the high sensing accuracy. Our system could be able to detect centimeter level movements in the indoor environment. We can also capture the very tiny movement when people are moving or breathing. The third advantage is the large sensing coverage. As I just mentioned, we could able to detect the people in the 10 meters range. And this actually overcomes the limited coverage of traditional monostack radars because the traditional monostack radars have the range limited. Okay, so these are the description of the single AP sensing architecture. And the second innovative point is the algorithm innovation. We use the hybrid algorithms. Based on the sensing theory, we incorporate a hybrid algorithm framework, and we combine the model-based signal processing and AI-based deep learning inference. So this innovative algorithm design enables detection of extremely weak signals, and we could able to recognize very small movements during human breathing and support accurate sensing of completely stationary users with only a single AP. This is the end of this presentation. Thank you for listening.
Thank you, Ms. Tang, for your detailed presentation. So CSI sensing certainly sounds like an incredible technology. But what are some innovations that this new tech brings to specific applications? As in, how will it change the way we work and live?
Okay, so and just now, Zhuqing mentioned the new technologies for the channel state information. Actually, I'm still thinking how to use the CSI in the different industries, in different scenarios. I try to summarize 5 application scenarios, and let's see. And before I talking to the application scenario, I'd like to mention again for the Wi-Fi CSI, the key difference compared to the other vendors. I think the most important thing is Huawei only need one access point to achieve the CSI functionalities. I think this is the biggest difference. Compared to the other vendors, okay, the other vendors can use 2 or more access points to collaborate with the CSI functions. And even though all these functions is the IEEE standard, but I think due to the customer point of view, they want to deploy the less access point to achieve the same functionalities. And the second thing is, as we know, for the radio side of the Wi-Fi, it's really complicated to do the deployment and to calculate the status. So thanks to the new technologies, for example, the smart antennas and also the new AI-based algorithm, okay, we can try to decrease the interference by each other. For the radio side, it's more clean, and then the result for the CSI could be more accurate. Okay, and for the CSI application scenarios, I think normally in the office, in the meeting room, and also in some intrusion detection scenario, and also even in the campus dormitories, in the hotel hospitalities, we can try to deploy the CSI functions and get more benefit to the end customers. Okay, so let's see one by one. And the first scenario is for the BEMS, the Building Energy Management Control System. And normally in the office, in the building, that has many rooms. And for each room, we want to control, we want to manage the light, the air conditioners, the curtains, something like that, all the facilities. So in the traditional way, we can deploy a dedicated network for controlling the facilities. And it's a siloed, right? One network is for the data communication, for the wired and the wireless, and the other system, the other network is dedicated for control the facilities. Okay, this is the traditional way, independent, the sensing and the control system. And in the traditional solutions, we need a dedicated IoT gateway and connect to for example, the infrared, millimeter wave sensors, and to detect and to control the light and the air conditioners. But now, many customers, more and more customers, they want to combine. They want to build the more convergence, the network. So that means the requirement to the network element, for example, the access point, okay, should have the capability for detecting the all the facilities. So, and you can see now, we have the Wi-Fi CSI sensing capability. With this capability, because the CSI is embedded into the access point, okay, with this capability, we can build the all-in-one solutions, campus network solutions. Only one access point. One access point can transmit the data, and as well as they can do the detection, and they can collaborate with the energy efficiency management, for example, and to get all the information from the radio site and send the information to the platform, and the platform can send all the control to the different devices. Okay, this is all-in-one solutions in the meeting room or in the building. Okay, this is the first scenario. And the second scenario, especially in the meeting room, you know, in one office that has a many meeting room. Meeting room is a mandatory for the every enterprise. So how to decrease the efficiency? How to decrease the energy using for the meeting room, and how to increase the efficiency for the meeting room? So many customers, they want to deploy a dedicated the sensors to detect in the meeting room. Is there any employees or not, the usage, the utility situations? But they have to deploy a dedicated sensors or the cameras. Many customers said this can waste more money to deploy that. They do not want to use it. So a new technology, the CSI comes out. We can use one access point with CSI functions to detect in the meeting room, is there any employees in, or it's vacant. So the Wi-Fi CSI sensing can collaborate with the conference management platform and automatically release unattended conference room resources. So this can improve the room utilizations. Okay, this is the second scenarios. And here I like to give you some reference. And the first reference is from our own as a Huawei Nanjing Research Center. The Nanjing Research Center has more than 20 buildings, and for each building has already deployed the CSI function inside the access point. So by deploying the CSI functions, the OPEX and the CAPEX can decrease dramatically. So we can use the CSI function. We can see the status in the meeting room, and also the facilities inside the buildings can save the hardware investment and also can increase the efficiency of inspection. And another reference is we deployed in Shanghai, the Shanghai Institute of Architecture, Design and Research. And here they have a historical buildings for more than 70 years. They want to refresh all the network and all the sensing system. So by collaborating with Huawei and the Shanghai Institute of Architecture, Design and Research, they built a brand new campus network. So with the Huawei Wi-Fi 7 access point embedded CSI functions. So these new architectures, actually they want to upgrade its conference system first. So when the people enter the meeting room, the screens and air conditioning automatically turn on. And as soon as they leave, the system immediately turns off the light and screens. So this is the real life scenario happening at the Shanghai design buildings. So CSI technologies has endows the building itself with intelligent sensing capabilities and meeting people's daily requirements. It proves comfort when people are present and save energy when they leave, turning the building into a thinking structure. So this has helped the building reduce its overall energy consumption by 15%. The intelligent renovation of the Shanghai Institute has paved a sustainable path for all future building renovating. I think this is by far, this is the best example, best reference for the synergy between technology and network design. Okay. And the third scenario, I like to mention how to do the person intrusion detection. So, in some company, they established the different zones. Okay, for the top secret zones, it's a red zone, and the other zones is green zone. So for the different zones, they have a very strict regulations. Only the authorized people can go to the right zones. For the person intrusion detection, in the traditional way, we can use the camera, we can use a sensor to do that. But this traditional architecture that has an issue is how to protect the employees' privacy. So with the cameras or with the sensors, we cannot solve these issues. And now with the CSI function embedded in the access point, we just can use the CSI, we just can analyze the radio side of the access point, can do the same things. I think this is the huge progress for this scenario for the person intrusion detections. And the fourth scenario, we can imagine in the universities, in the dormitories. In one dormitory that has 2 to 4 students in the dormitories. But in some universities, they want to know the real situation when the students is in the dormitories or in the classroom, and is there any security risk or not. So in traditional ways, could be they use some cameras, but this is the privacy issues. Could be they have some the sensors, the privacy issues as well. So now, in every dormitories, we can deploy one access point that has 2 functions. One is for the students to connect to the internet, and the other things, I think important things, they can do the campus management for the CSI. Okay, especially during holidays. Okay, they can detect if some dormitories cannot turn off the air conditioners, and they can save the energy, okay? And also, here I have a reference in China. We collaborate with a top university in China. And at the beginning, the classroom used the infrared sensors and cameras for monitoring and energy saving control. And now we can use the access point, the Huawei's Wi-Fi 7 access point embedded the CSI capabilities. We can achieve the power off when no one is present in classroom. And this access point can also be linked with the meeting room reservations. And before the campus network upgrade, the cost to refresh a single classroom was more than 2,000 RMB. And now, because the new solution is integrated solutions, no need a dedicated the sensors and the dedicated IoT gateways. So, and currently, the new solutions for every classroom, the expense can be reduced to 500 RMB. And furthermore, the number of maintenance personnel has been cut by 80%. And the energy consumption for the air conditioner system has decreased by 30%, okay? And the last scenario is for the hospitality industries, especially in the hotel. So, and normally, actually in hotel, there had some issues. For example, the fraud detection. Some employees could commit fraud by not recording guest actual check-in information, and they do some improper benefit. And another requirement is, okay, many luxury hotels, they do not want to use the electricity cards to get power. So they want to show the hospitality to the guest. When the guest goes out in the hotel, should have a dedicated methodology to detect and then turn off all the light and air conditioners. And now the Wi-Fi CSI can do the same thing like that, okay? So we deployed in many hotels in China and overseas China. So through the CSI, the access points are no longer just tools for internet access, but have to become the never-ending hotel rooms. Actually, make the hotel room as a smart guest rooms. And furthermore, we collaborate with our partners to do the joint innovation solutions. For example, from the terminal layer and also to the network layer, to the control plane, to the application layer. We want to do with our partner the end-to-end solution for deploying the CSI in hotel scenarios. Okay, so that's my share for the mainly 5 scenarios and deploying the CSI functions.
Thank you, Mr. Han Liu, for your excellent presentation. So from those real-world examples we just looked at, we can clearly see the powerful capabilities and broad scope of application of this new Wi-Fi CSI technology. Now let's move on to our much anticipated panel discussion, in which our 2 industry experts will dive deep into some industry questions. The first one for Mr. Han Liu is, what other industry applications does CSI have?
Okay, and just now I introduced the 5 main scenarios. And furthermore, we can imagine in many industries, we also have the ideas for deploying the CSI, help the end customer to do more things. For example, in the healthcare sectors. And normally the personnel perception capability provided by CSI in the healthcare industry, especially in for example, the senior care center, in the traditional way, okay, in the senior care center, the safety status of the seniors normally determined by the monitoring the electricity usage and also by the community personnel. So this is actually very important, very difficult to detect and to make the decision. So now with the CSI in the future, the CSI can be combined with the millimeter waves capability to detect the vital signs for the seniors. And this can help us to do more things in such healthcare scenarios.
Okay, thank you. So the next question is for Ms. Tang. What are the current challenges and value of AI tech development in the field of Wi-Fi CSI sensing?
AI is actually very important in the development of the Wi-Fi sensing technologies because the main reason is that AI actually helps the Wi-Fi sensing extract much richer the patterns from the CSI. But all these rich patterns cannot be easily extracted by using the traditional signal processing algorithms. This means better accuracy can be achieved for the processing detection, behavior pattern recognition, or even tiny moments like breathing. Also, AI is more adaptable across different environments, like different layouts, different materials, or multiple people moving around. So based on the value of AI, that is the reason we have founded two competitions. All these competitions, we would like to explore solutions, innovative solutions based on AI. Also, there are challenges, as you just mentioned. The major challenge is that the CSI data is actually very hard to collect and label. And also the CSI formats differ across different vendors. And the AI models don't always generalize well from one room to another. And because of these challenges, we founded the Sensing Dataset platform. So this platform provides a high-quality sensing dataset to support AI model training and the development of Wi-Fi sensing.
Great. So the third question is for Mr. Han Liu. Besides the ones we just talked about, what are the advantages of CSI sensing over traditional sensing technologies?
Okay, so in my opinion, that has two advantages compared to the CSI and the traditional sensing technologies. I think the first one is can decrease the OPEX and the CAPEX because for the CSI embedded into the access point, no need the further equipment to do the deployment. And for the traditional sensing solutions, okay, we have to use a dedicated IoT gateways and dedicated methodologies to do deployment and maintenance. This is the first thing. And the second thing, I think most important thing is privacy protection. So for the CSI technology, CSI actually detected this turbulence in the channel information space and doesn't perceive specific personal privacy information. I think this is the big difference. This is a significant advantage of CSI over traditional camera surveillance methods, as it effectively protects the personal privacy and avoid the exposure of private information.
Great. So the next question for Ms. Tang is, what are the common issues that we're currently seeing in the implementation of Wi-Fi sensing technology in the industry? And what contributions can standards make to address these issues?
Okay. Today, the industrial still faces several challenges, I just pointed out, in bringing Wi-Fi sensing to the real deployments. There are a few problems. Most existing Wi-Fi devices were designed only for communication, and this is the major problem. So because of that, the CSI quality is quite poor. And also the deployment is also highly environment dependent, which makes the performance vary a lot from one room to another. And before the standard is finished, each vendor uses its own CSI formats and APIs, so the interoperability across the ecosystem is still weak. The standard could help to address these issues. The 802.11bf unifies the CSI format and defined the dedicated sensing waveforms and standardized the measurement and reporting procedures. And this kind of efforts reduces the fragmentation and strengthens the interoperability and give the chip makers and device users a clear technical baseline to build on. Although the standard cannot solve every problem, every engineering problem, like the hardware limitations or the algorithm performance, but it provides the common foundation the industrial needs to scale Wi-Fi sensing in a consistent and reliable way.
Okay, great. So the final question for Mr. Han Liu is, what are the deployment methods for CSI applications?
Okay, and actually the deployment method for the CSI is really flexible. So we can deploy CSI with the partnership or direct with the customers. And furthermore, for deploying the CSI functions, the first thing is we should enable this function, CSI function, in the access point. Then the access point can do the calculations, collect all the information, CSI information, and then calculate and send the result to the control plane. And then the control planes, the northbound interface, it's a standardized interface connect to the third party's platform. The third party's platform can get the information and then shows to the customer and do the more control. Yeah.
Okay, well, thank you both again for your insights. So in today's presentations and discussions, we looked at the entire process of Wi-Fi CSI, from standards development to practical deployment. We also looked at Huawei's contributions in this area, as well as the practical value of Wi-Fi CSI technology in various industry fields. So once again, I'd like to thank our guests for their excellent presentations and thank everyone who participated and supported this event online. If you're interested in today's topic, you can follow Huawei's official channels for more information. And on the IP Club website, there will be more activities announced soon. So to everyone watching from around the world, I'd like to wish you a good day, good afternoon, or good evening, wherever you are. See you next time.
See you next time.